Hello everyone, this is Fahad Mirza and I welcome you to my channel. Every day, dozens of papers get released on archive. Most of them are related to machine learning and AI. I appreciate the effort which goes into creating these papers, but not every paper is really up to the mark. And that is why whenever my eye catches a paper which seems promising, I really cannot wait to share it with you. I think this paper, which is titled as InstCache, a predictive cache for LLM serving, holds a lot of promise. In this video, as is the spirit of the channel, I am going to explain in very simple words, in a very short way, this paper to you without any fluff. I'm not going to go into the detail of any machine learning mumbo jumbo. We will keep it simple and separate, and I would explain it to you in very simple words what is happening here. So let's get right into it. Let's set the stage first and see what exactly is the preamble and requirement of this tool. As we all know, these large language models are transforming various aspects of life. They can understand and generate human-like language, but they require significant computing power, resulting in delayed responses and high energy consumption, not to mention the cost. To address this issue, researchers have proposed using caches, which is a small, fast memory that stores frequently used data, such as key value cache and semantic cache. These caches reuse previously computed results to reduce computational intensity, but they have limitations in terms of scalability due to high memory costs. That is where this new research comes into play, which is called as InstCache. This InstCache is a predictive cache for LLMs. InstCache uses an instruction aligned LLM, which is a type of LLM that is specifically designed to understand and generate instructions. So this instruction aligned LLM is used to predict user instructions and store them in a cache. This cache is then populated using a negative log likelihood or NLL based algorithm. This NLL is a mathematical method that predicts the likelihood of a particular instruction being used or not. This approach enables the cache sizes at hit rate, which is a percentage of instructions that are found in cache, to be predictable. InstCache is implemented as a hash table. A hash table is a data structure that allows for fast lookup of instructions. So this InstCache, which acts as a hash table, minimizes lookup latency, and that is a big deal in my humble opinion. Experimental results have shown that InstCache can achieve a hit rate of up to 51.34% on the LM6 dataset. That results in a 2 times speed up. This means that the half of the user's instructions can be processed using only the CPU and its memory, significantly reducing memory and energy consumptions. The proposed InstCache can be deployed, and existing LLM serving systems provide an efficient and scalable solution for LLM based applications. If you look at this diagram, tells you that this tells you about distributed cache pre-population. So let me first take you to the previous diagram because that basically provides the foundation of the next one. So in this one, unlike traditional caches that populate with incoming requests while being deployed, InstCache decouples the population phase and deployment phase. During pre-population of the cache, InstCache will be populated with all LLM predicted instructions with negative log likelihood below a selected threshold. The hit rate and cache size can be accurately determined by the threshold, and then they search these instructions by generating next tokens with an LLM step by step, forming a tree structure as you can see on the right of this diagram. The inst-aligned LLM is an LLM fine-tuned with instructions in the training set. After pre-population, each path of the tree will become an instruction stored in hash table with corresponding answer. And then finally, InstCache will be deployed with existing LLM serving systems, accelerating the inference process. Now, if you look at this diagram, this makes more sense. So here we are looking at distributed cache pre-population. So the master server is building the base tree with a limited depth less than maximal depth. Each path of these base tree serves as a starting node for subtree generation in slaves. Subtrees are iteratively merged with base tree, forming new base tree for subsequent pre-population until the maximum depth is reached. So that is all what is happening here. So if you just want to say what exactly is InstCache, it is based on observation that most instructions are short, repetitive and predictable by LLMs. And this involves predicting user instructions by an instruction aligned LLM and storing them in a predictive cache. Now, there is a lot of other information which is scattered throughout this paper. I would highly encourage you that if you're looking to for any low latency solution, maybe this research, when it becomes a tool, could be quite beneficial, because not only it is reducing latency, but it is also promising to deliver a predictable level of performance, which is extremely important in sort of edge applications. Now, before I let you go, let me also introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language for extracting data from web pages quickly, easily, and at scale. You can use its Python SDK to run your queries in production using Playwright, and use the browser-based debugger for optimizing queries in real time on any web page. AgentQL is a robust alternative to fragile XPath and DOM CSS selectors, as it uses the power of AI to analyze the page structure to find the data you are looking for. And I will drop the link to their website in video's description. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network, as it helps a lot. Thank you for watching.